So question number 14, it says solve each equation for x by completing the square. And really it's just using the same completing the square steps, but we now need to keep track of some parts algebraically because of that unknown k that we have here. Okay, so we can do this any way we want, but essentially we're trying to make a square so that we can undo the square and solve for x. So for a, we're going to have x squared plus 2x is equal to k. Okay, I'm going to show the box here. So we have our x squared, we have our 2x's symmetrically distributed here, and then we need to solve for that extra box in here, and that completes the square. So this is a square that we need to complete. We needed a 1 there, so we're going to do plus 1, and that completes the square. Now when we're completing the square, we have to remember that that was not there to start with, so we need to then do a plus 1 on this side. Once we've completed the square, we're going to write it in its squared form, and then we're going to undo this square by square rooting. So x plus 1 equals plus minus the square root of whatever k plus 1 is. Remember that we can't apply the square root when there's a plus. We're just going to solve for x by subtracting 1 from both sides, and there's our solution for x. Okay, we completed the square, and then we isolated the x. For b, we'll do the same thing. We're going to set this up as kx squared minus 2x, and that's equal to k. Now, with that extra k there, it's going to be hard to make a square because the k is not necessarily symmetrical. It's not necessarily a square, and we need a square to start with up here to be able to complete the square. So the first thing we're going to do is divide everything by k. Okay, so now we have a perfect square form, a squared, and we can now complete the square here. So I've got my x squared. I've got to distribute my middle term symmetrically, so I'm going to have 1 over kx here, 1 over kx here. That's going to give me my middle term, so that should be negative. And then I can see that to get the negative 1 over kx, I need to minus by 1 over k here. I need to minus by 1 over k here. So I take half of that and square it to complete my square. Okay, so to complete my square, I'm going to end up with 1 over k squared. So half of the middle term squared gives me 1 over k squared. So once I've completed my square, I have to remember to balance my equation. I'm just going to slide this over a little bit. I'm going to balance my equation by adding the same thing to both sides. Now I have my completed square on the left-hand side, so I'm going to factor. So I'm going to end up with x minus 1 over k squared, and that's going to equal 1 plus 1 over k squared on the right-hand side. I've got my square. I'm going to undo the square by square rooting. X minus 1 over k is equal to plus minus the square root of 1 plus 1 over k squared. Okay, solving for x, I get 1 over k plus minus the square root of 1 plus 1 over k squared. Okay, now we can leave it like this. This is perfectly okay. Do not square root those two parts because there's a plus there, so we cannot apply square roots when there's pluses. We can do, so this is good enough. We can simplify this to a common denominator, and to do that it would look like this. Maybe I'll do this in a separate color because this is just cleaning it up. I'm going to make it look like the quadratic formula form. So it's going to be the square root of k squared plus 1 over k squared. I got a common denominator here, and then when I square root the denominator, I'm going to have a common denominator for both parts. So k squared plus 1 over k. Again, do not apply square roots across pluses. And then I can rewrite this as 1 plus minus square root of k squared plus 1 all over k as my solution. So this is just a cleaned up form of the original solution.